A, right? So I'm going to flip A over to the back side. How do I write the equation to go to the right? Did it go to the right by 2? So it would be x minus 2 in the absolute value. So this is graph A. I'm just writing A in case you get lost. This goes on the back. So that way, like if you're doing the flashcards, you could say, oh, I would put x minus 2 inside, because that would go to the right. Are you with me? So now I'm going to do B. I'm going to try to go through kind of quick. So are you? No, there is a Q. That was A. Are you done with A? Yeah, on the back. So you would show this graph to someone, like whoever you're studying with, or yourself. Write an equation for this function. How do I go to the right? Oh yeah, that's x minus 2 inside the function. Right? So it allows you to study with someone or by yourself the transformation rules. Can I go to B? And then the video will be there, or you can just have my A and B at the end. Just catch up wherever you are. That's A. I've only done A. Tell you what, I'll leave A up the same time that I put B up. So you all found B? This has been what? Shifted to the left this time, right? So on B, we would write x plus 3 to go to the left. So I'm writing on the back of the card the correct answer so that you could quiz yourself that went to the left. But you guys come with this method sometimes, don't you, for vocab? I literally saw someone studying for a French test, and they were quizzing each other the vocab. Yeah. Math, this is a lot of vocab. Can I go to the next one? C? Yeah? What happened to C? This is an up. How do I make a function go up? These are all absolute value, but it applies to every other function. So C, in case you need to know which graph we're on, this is going up. So you put the plus on the outside, and it went up by 1 unit. Right? So the plus 1 goes on the outside for the up 1. Good on that. You on D? So D is your down. I'll just kind of scroll that one up a little bit. So D is going down 2 units. So for this one is D, you would put absolute value with a minus 2 to go down 2 units. So those are 4 transformation rules you have to memorize. How do I go right and left? How do I go up or down? So those cards, if you just memorized for this function, you'd have them down pat. All right, E. What has changed about E? Do you see how E and F go together? Like, let's look at E and F. What's the difference between E and F? They kind of go together. Yeah, so we call this less steep. We think about it in steepness. So this one is steeper, and this one is less steep. How do I make something less steep? I throw a fraction in front of it. What's the slope of that line? Up 1 over 2. So for E, y equals 1/2 times the absolute value of x. So the 1/2 going in front of it, we call this less steep. Or you could call it a vertical shrink. So just to keep you from getting confused, I usually don't say that it's wider, because that's a horizontal change. If we keep it all focused on the vertical, I'm half as tall, so I'm less steep. If you kind of keep all of those adjectives together, then you won't get confused. Let's see, what's the slope for graph F? Up, how much? Up and over, up 3 and over 1. So how am I going to write the equation for F? 3 times the absolute value of x. So vertical stretch, or you could say more steep, or you could say steeper. But identifying that that value is doing that job. So let's see, the last one that I have doesn't really have a partner with it, because what happens with absolute value when you flip it over flip something over the y-axis, you don't see it, right? So I did not write that change down. But if you look at graph G, it has been flipped upside down. How do I flip a graph upside down? Y equals negative on the outside, absolute value of x is a flip over the x axis. You might want to just write like a side note, y equals the negative inside is a flip over the y-axis. Because I did not have that as one of the cards, but that way this card has what the flip over the x-axis and the flip over the y-axis, how it would be written. But this doesn't change the graph because it's symmetrical. Good on that one? Can I go to H? So H, you have to write the whole equation for the function. So I'm going right, 1, 2, 3, and down 1, 2, 3, 4. So right 3 would be x minus 3, down 4, right? So is that the right equation? Down, right 3, down 4. So x minus 3, and then the minus. All right, I is domain. So not a lot of practice on domain, but at least domain is thrown in there. What would the domain be for this function? Yep, so this is letter I. I'm just going to write domain equals x in parentheses for myself, and I'm going to write the boldface capital R, or if you want to write all real numbers. So that way on this card, I'm reviewing that domain is x, and for this equation, it would be all real numbers. Yeah. By the door. Are we good on I? Yes. Oh, you like cut off all the edges.
Yeah, I did. Who keeps the extra stuff? Just you.
I just did less cuts. Efficient. But at least thank you for not doing all that. Yeah. All right. So what is the range of the next one? So on is this J? J, write the range of the function. It looks like I'm starting at 1, 2, 3, 4 for y, right? So y is, yeah, aren't I on J? Write the range of the function. So y is greater than or equal to 4. And I want to write that range is the y values, maybe in parentheses. So that will help you with your 8 transformation rules and what domain and range are. I would recommend using the flashcards. That's why we made them. Even if you did them once tonight and kept them in your folder or wherever. Can I go to the next one? We're doing just a quiz, kind of like a vocabulary quiz on the stuff that we've been doing for a week now. Some of you haven't been here, so you just got to get caught up. All right, I got K and L up because we're just identifying parent functions now. So K is what? What type of function is K? K is a quadratic. So what I would do is, if you already know that K is a quadratic, set that note card aside. Don't keep doing the ones you already know, right? You don't have to go through all 24 of these. Go through the 10 that you don't know. What is L? Cubic. So then we'll do M and N. So K is quadratic, L is cubic. Did we get those okay? Can I move them? That's just K and L. I'm moving K and L. Okay. So then I got M and N. What is M and what is N? Linear and square root. Who said that? Zach. All right. So linear. See, you guys know these now. and square root. So I forget, linear was m, and square root goes on the back of n, just so you can see when you're out there. Mn, O, and P. Those are the other two parent functions in this list. Can I move on M and N? O and P are the same parent function, just with a different adjective. O is what kind of exponential? Increasing, and P is exponential decreasing. So O, exponential increasing, and P, exponential, or, abbreviate. If you don't want to write out the whole word, these are your flashcards just to help you study them. I bet Q and R you don't even really have to have in your stack, but they're just another domain and range question about linear functions so that you're practicing. Can I move O and P? What's the domain and range on both Q and R? Linear functions are always what? Can I go forever side to side? And can I go forever up and down? So both of these are just all real numbers. All real numbers for Q and R. This was card Q, this was R. So if it's a linear function, it's going forever, so it's just all real numbers. Q, R, S, T, let's see, S, T. Write the x-intercept and write the y-intercept. So let's see, S is the x-intercept. What would you estimate the x-intercept is? Yeah, maybe 4.5. So let's see, S, how do I write an x-intercept? 4.5, comma 0. Let's see, what does my y-intercept look like? It's 3, right, for card T. So 0, comma 3 is the y-intercept. So this is the x-intercept and this is the y-intercept. So we're just writing what the x and y-intercept was on the graph. STUV. That's 4.5. The x comes first. Oh, it's alphabetical order, x, comma, y. Can I move it? All right, U and V talks about increasing or decreasing. You might want to circle on the graph where it's talking about. So from 0 to 1 for x, I actually want you to circle this section of the graph down here at the bottom, right? Because that's between 0 and 1 on the x-axis. Is that increasing or decreasing? So U is decreasing. So the other one, where should I circle on the other graph though? Between -4 and -2 though, it's actually still decreasing. I put it on because students mess this up all the time. They see the arrow pointing up and they think that this is increasing, but you always read a graph from left to right. So this one is still decreasing between -4 and -2. So V is also decreasing. The last two I was going to throw away, but we're literally doing these next week. So I figured it doesn't hurt to have them in your pile. We're going to learn the difference between vertex and standard form if you haven't learned that already. So I figured we could just leave these in the pile and then it'll make sense next week for your, studying unit 2. This is called standard form when there's all 3 terms written out like this. So X, when it's the 3 terms, is standard form on the back. And, W actually comes first, right? W comes before X in the alphabet. When there's parentheses, that's called vertex form. We're going to look at that a little bit tomorrow. W. So W is vertex form. just so you have them in the stack. So now you have 24 little resources to help you keep practicing the transformation rules and everything. So what do we have? 5 minutes before lunch. So rather than I wanted to do a little bit of notes today. Why don't you use your note cards and turn to page 208, which is it says quiz review, I think, right? I think in 5 minutes you should be able to get done a fair amount of these questions. Identify the parent function, find the y-intercept, identify the domain. This would ask you for the local maximum. Does everyone see page 208, that quiz review sheet? See what you can get done on that in about 5 minutes. We're going to come back to this after lunch, but we also are going to do a little bit on quadratics to move us ahead after lunch. I just thought this was colored, but it's famous. Yeah. I thought it was like white when you colored it. Oh, you want help with those two colors? Yeah. Everybody have 208. 208, you all got 208? You got 5 minutes. See if you can get 1, 2, and 3 done before lunch. Yeah, I can cut the scissors. Or you could sit down, put the scissors in your side pockets or side basket so that my next class has them. These are the answers to the quiz review sheet. And this is the answers to the back. Oh, what day is on March 14th?